Hi everyone, this is Gaurav again. So today we'll be covering few topics like if you have some data sets, uh, you have imported one data set and some values are missing in that. So how you will be replacing those values, right? Uh, which analysis need to be done or which value you will use to replace those things. And again, after that, I have already discussed in last class that how to find out the outliers. Okay. Today also we'll do one more thing. In one data set we will do. Okay. We will find out the outlier in one data set and then we'll remove those values. And after that we will cover up one more topic if time permits. Okay. Okay. So if you have any doubt from previous class, you can ask me later also. Okay. For now, we are just starting. Any question? Okay. So let me share my screen first. I think this thing I can share. Okay. 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 You can see my screen. It's fine. Uh, my Jupyter is open. You can open your Jupyter file also. Okay. There. Okay. So let's start with basics. Go to your files. Wherever you have created that particular folder, uh, you can create a new file. Right? Here will be working. So mostly this is also Python basics only, but some Python basics topic or basic functions. What can I say? What we were writing Python basics 2, 3, 4. So I Python day 4. Just okay. So we'll start with the basic thing. How to find out the missing values. So last time I have sent you one file, right? That Pokemon file, Pokemon data. So this time what I did in the same Pokemon file, I have, let's say, some values. Okay, some values were missing. Okay, I have deleted few values. If you go to data and filter, and if you see in attack values, okay, some values are missing. Clearly analyze, there some values are missing. Okay, and if you only want to see which values are blank, so you will see that there are few values, right? Okay, for some column names or few rows, there is some missing data for this particular attack, which we cannot miss out, right? We need to give some values to these values. Otherwise, either we have to remove them or give some values here. So if the values, if the data, right? If some values are missing, what mostly we'll do, we'll replace with some of the mean part, right? Some central values. So it can be mean, median, and mode. Anything can be there. So based on our data, right? Depending upon the data, how this particular data, that particular column, how that data is distributed in that particular part, we will impute those values. So imputation means replace. You will replace those values with some central value. So if the data is skewed, okay, if data is skewed means, let's say you have some outliers. Okay, you have mostly your data is between 1 to 10 and some of the outlier they are coming, let's say from uh, 50 to 100 or something like this. Okay, your data is skewed. So in this particular case, okay, you won't be able to use mean, right? If you use mean, then what will happen? Let's say one or two values are missing, and because of those outliers, let's say 50 or 100, you will be getting some higher mean value. So if you replace those missing value with one higher mean, then your data, you are literally taking it to another side, so your analysis won't be perfect. Okay, so at that time, based on the data, either you can replace it with median or mode. Okay, mostly we'll replace it with median values. Okay, but in case of skewed data, if the data is not skewed, there is no outlier, everything is fine, then we can replace it with mean also. Okay, Now I will send you this file. Okay, from chat box also I can send file your PC. Let's I will send two files. This will also be handy. Last only one file I can send. Okay, Pokemon data. Okay, I've sent you the file. You can also open it. Okay, you can see the same thing. So just to get this particular Pokemon file, right? This is in our working directory only, right? So in the same folder where I've created this particular Python file. So let's start with basics, right? We can use pandas, right? We can use pandas to import file. We'll use panda to import file. And how will we read the file? Last time also we did df.read csv file. This is csv file, and we will reading that Pokemon data. Pokemon underscore data dot csv. I think file name is this only. Let me check again. Yes, this file name is that one. So you can also print this particular data frame. Okay, I think most of you are now familiar with pandas, numpy, and how to draw diagram, all these charts, plots, and everything. Okay, so today it will be hands-on. What it is saying, no module as panda. Oh, why it is saying no module panda? Let me restart this. Sorry. I missed something, right? I have only written panda. It should be pandas. Okay, close this. Channel is connected. Fine. It's pandas only. That's what I was saying. Okay, it is running, right? To get some number here, it means it is run. Right? So it is saying it is connecting to kernel and replacing stable connection. Let's see. Okay, so whenever it will run, we'll see that. Now we can also print, right, what's in the head. So simply just to know that what exactly in the data, right? So we'll simply say head 5. So we'll get the top value, right? And okay, why it is not coming? Let me restart the kernel. Has anyone doing this thing with me, or they're just there for
No, I'm doing, but then it's giving me error that name DF is not defined.
name df is not defined? Okay. Anything? Okay. So that's what I was saying. You should not copy everything. Okay. There is no df, right? Yeah, it is not there. The library we are importing it as pd. Okay. So
Yes.
yeah. So it's not a test for you. Just you should not copy everything with the right? You should use your own mind also. Maybe there what kind of error you may face, right? So you will be able to debug on your own. Okay. So once my this kernel thing runs, kernel started, I think let's enter. If I run it, yeah. Sometimes when you close this kernel and all, you'll get this error. So it will take some time. Okay, last time sir was facing this issue, now I will facing this issue. Just few minutes ago it was working fine, and just when the class starts, this kind of error appears. Okay, so it's not working. Just a second, okay? Just give me a second. I'm stopping the recording just for a minute. So I think whenever this particular tab opens, we should not close this tab also. This first tab, no, this is also work as a server. So if you have closed it by mistake, then this kind of error will appear. So this terminal, this kernel, this should run. Okay, you should not interrupt it. And whenever this particular tab opens, okay, you should keep it open also. Okay, now it is working fine with me.
So
Now,
Gaurav, can you share this file again? I mean, I've had some issues. I have
okay.
deleted that file.
Okay, no problem. I will share again. Okay. I will share. Okay, I've sent it again. You can download
Yes.
right now. Okay. So here, what I did from previous one, I simply deleted some data in attack part. Okay, I have deleted some values in this attack one. Okay. So here,
If
if you
somehow I'm not able to save it as CSV file.
then you can save it as XLS also.
I mean, so save as type all files is what I'm able to see.
Yeah, you save it as all files, and there you will just write in Excel .csv extension. You give .csv if you are having this issue.
Okay.
Yeah. So here we have this particular file. We have this header one. Okay, and here let's see what we have it in attack. Df dot. Okay, how will we get the values which are in attack? You are
Okay,
able to.
now
Yeah, it's working fine.
let me run this in Python.
Yes. No, don't worry. Okay, total 800 values are there. Okay, and okay, now what we need to do, what we are exactly trying to do, we are trying to remove some values, okay, in this particular part, right, in this attack. Here, let's say I'm not able to see, right, if something is missing. Okay, then what will I do? Okay, we'll see. So this thing we did. Now we'll plot some diagram. Okay, which kind of plot we can take? Distribution one, box plot, or something else? Now let's see. Okay, now you have this particular data frame. Okay, do you know how can you find out mean? How can you find out mean? Anyone?
df dot mean.
Yes, that's simple as that. Okay, and if you need to find out the median of this particular one, what will be the one? Just instead of mean, you have to write median. Okay, so and if I want to, let's say, plot some diagram, okay, to I want to plot some box plot or something like this to find out how this particular data is varied, right? So there are some last time what we used math pilot library, right? So there is one another library also. Okay, a similar kind of library. Okay, Seaborn library is there. Okay, you can use it as an SNS, and this library you simply try to plot the box plot SNS dot box plot, and here will go box plot of DF.
Gaurav, are we recording this?
Okay, yes, this is getting recorded, right? Yeah, stop sharing. Pause. It's getting recorded, I guess. Pause recording, I'm guessing, which means yeah, that was getting recorded. Okay, so don't worry about that. And let's see if I run this. Okay. Oh, I did not get anything. Why? Okay, I have not passed any parameter here, right? So in box plot, I want to plot a box plot or let's df attack. Okay. Okay, it gave me some warning, but you can skip it for now, and you will see that mostly your data, right? it's between around from 50 plus to around approximately 100, and outside this particular 160 or 170, some outliers are there, right? This is also one way to plot this particular box plot. Okay, so now we have this value, right? What we can do, the simple formulas are there, right? If let's say we have some different kind of data, some categorical data is there, right? Let's say male, female, or something like this. During that time, you cannot use mean, median, right? At that time, you have to use mode values only, right? Whichever value is coming more number of times, you can replace those missing values with that mode value. But here, let's say we want to replace it, right? So mostly if data is not mostly skewed, okay, one distribution plot is also there. Okay, let me give it, let's see if this thing will distribution plot, and here we'll pass this particular value. Can we run this? Okay, S and S, okay, S and S was there, right? Okay, okay, that's how my data was there. So is it a skewed data or not? Tell me, anyone?
No, it's okay, I think.
It's okay, right? It's not that much skewed,
So we
right?
can check, but yeah, with
You can check the skewness,
one
but just
uh,
with this, see, after seeing this note, what
not
do you
skewed.
think? It's not skewed
Fine.
data. Yeah, it's fine, right? Because mean, median, both values are almost nearby, right? 75 and 79. It's not much difference. But just if it would have been skewed, then mean value would have been much higher or maybe much lower because of some particular value. Okay. So here data is not skewed. Mostly it's fine whether we replace it with mean or median, right? Both are fine. So here, let's say we want to replace it with mean. So how will we do that? Okay. So just a second. Okay. My phone. Okay. So here, this particular data. Okay. So I want to fill it some values in it. Okay. Fill NA. There is one function called fill NA. Whichever values doesn't exist in this particular file or this particular data frame, it will replace it. Okay. With which value it will replace? We can either define it earlier or we can write here also. Let's say we are defining some value here. Let's say I'm defining mean value mn, mean of attack. Mean of attack is what? Is it fine if I go this slow? All you will be able to understand, right? Otherwise, I can go a bit.
Yes, Gaurav, but then I'm getting some error message when I'm doing this sns.dist plot df attack. So it's saying cannot convert NAND to integer.
Okay, but okay, you're for which part you are getting error?
This this sns.dist plot.
So okay. Uh, Give me some time. Okay, we'll get back to you. This is warning you can get. Okay, warnings they are because of
I'm
some
getting
library.
warning, but then there is a error as well.
Have you written like this only? DF attack. You have written the same thing. ATTAC kit. Name should be same as the column name, right? You will
So I
definitely
think
get to know.
name is same df, then attack attack.
Okay, this library may not be in your system
No, this is there because I was able to do that box plot.
earlier.
Yes.
Okay. Okay, we'll see. We'll see. There may be some
DASC.
different kind of level. Yeah. So if
And
you
also
whichever,
somehow, I mean, the bracket is in black color and yours is in green. But I mean that
yeah,
not sure.
mostly when we go to these things now, when you go to settings and all, these things you can change, right? So many things are there. Okay.
And now I'm doing it and receiving.
Yeah, user interface and everything. If you edit it, you can have some different options how this kind of thing will show to you. Okay. So get back to you now.
Okay.
Okay, so I want to replace this particular mean attack. Okay, I'm replacing it. What do we call this imputation, right? Well, let's say our hand is cut. I want to replace it with something. So I will only use mine only. Na? I cannot use other person. Let's say even for skin also, right? Skin you can, let's say, change, but hand is a very different big part. But here some skin is not there, then it's fine. A few data points are missing, then you can replace it. But let's say 50% data points are missing, then you have to think a lot, right? Let's say very few data points are missing, then it's fine. You can replace it with mean, median, mode, depending upon the logic, right? Depending upon how the data is skewed or not, what kind of distribution it has. So now we want to replace it with some particular value. So we are replaced now here. We are saving this mean as mean attack, and we are filling this particular data as mean attack. I think this thing is there, mode is there. Okay, before let me check. It will work. Okay, which value I have in mean attack? Fine. What if I write like this to give me same thing? Okay. Okay. Skip it. No. Basically, now we have to save it, right? Otherwise, these value will get lost. So in df attack, in this particular data frame, we are filling whichever value is nil, we are replacing it with mean. Run. Okay. Now again, if I want to check the mean value, this would have been changed. Then okay, sorry. Yes. So what was our mean earlier? 79.079. Now also it is same. Is it run or have we did it wrong? No. Okay, I'm taking some time though, because these things are very minute thing, but you should do it very carefully, right? This is more of a like a practice session for you also. So if you get any error, plot object is not scriptable. This is a plot thing. Okay, this more. Okay, if I do just save the attack. So the okay. So in my file, let me again check it out. Which data point it was missing. Here also you can check, there also you can check. Okay. So index number 21, 40, and 52. If you want to find out using Python, you should give it a try. Okay, you should run a loop, or you should find out some functions, right? Which value or which index it is empty. Okay. So if I want to find out, I can Google it also. Okay. But I'm skipping that part. I think you should do it with search of that. Okay. So no, I should not skip it. Okay. Let's say I want to find missing values. Missing. Let's okay. You can Google it and you can find out that which kind of function you can use, right? You will get so many things are there and everything is there. Okay. So you can search it out. Okay. Now I have replaced it with mean. What if I again want to run it? Okay, I'm again reading the same file. Now I have the original file, right? I have in df. Now what will I have? I will have the original attack one. Okay. So if I want to see it again, okay, this is there. So what is my mean? 79 million. Okay. What if I want to replace it with median? Okay. So 75 is there. Okay. So instead of mean, I replace median. Let's see this was. Now if I run it again, and if I want to check the value, okay, not, it did not change. Okay, so like this, you will be able to replace those values. Okay, and here, okay, df attack is there. Now I already replaced it, right? So these values are there, right? Some functions are there, fill and all, right? Some other functions will be there in some other libraries. Okay, you can find out, you can Google it, and before doing anything in the data, right? This is the most important thing. You should be able to find out those missing values or at which particular indexes it is missing. Then you can replace it with mean, median, and mode. I told you some theory behind it, some logics behind it, that if data is not skewed, you can use median. But if the data is skewed, then depending upon situation, mostly you will use median only. So just find out the median and save those median values within those empty frames using these functions, and you can do that. Okay, now next part is last time what we were doing, we were finding outliers, right? I told you one function also, right, for that outlier one, right? So to find out those indexes, you can use this function, that particular logic, right? There's some other logic also for z. You can use, you can find out using z, or yeah, using z values also you can find out. But okay, for now what you should do, last time I think sir has used that Boston data, right? Boston data is there, so I'm sending you the code. Okay, you can also load this particular data. Okay,
And Gaurav, I mean,
yeah.
were you try to, I mean, so are you able to backfill this median thing? Because I have done this, I mean, this fill NA with median attack, and then I took mean, and it again, it's coming exactly same.
That's what I was saying. I think I'm missing something here. Okay,
Okay,
I
okay,
will, I will check it again. Okay, maybe I'm missing something here.
okay.
Okay, and if I remember it, okay, then I will get back to you in
Sure,
this session
no
only.
problem.
Yeah, okay,
Okay,
okay. But
yes,
I will show you some way. Okay, these
sure.
are like syntax only. Okay, you can change the syntax. You can use other formulas also, right?
Okay,
But
okay,
this is the way, because without using box plot and this particular kind of plots, you won't be able to see, or without getting the skewness of the data, right? You won't be able to find out that uh, how this particular data is varying. Once you get to know this, you just need to know that with which value it need to be replaced. Okay, if you know this, then it's a piece of the, then you will be able to do that easily. Okay, now last class
okay.
sir has told you about Boston data, right? And last class I think Sagda sir, I think he has used Boston data, right? So you can also run it. It will, okay, it is not that fast. Fine. So in that Boston data, there were so many points were there, right? Here also we can use, but just for namesake, let me try with this Boston data, right? Let's say now in this, if I want to know the column names, okay, then what I have to do, the data, it is in Boston, BOS_HOU. Okay, in this data, feature names are there, right? I run it, what will I get? Okay, now these are all column names. Column names are there. Okay, you can also save it with column names. Now after this, this is your data is in this. So you take the data of this. Okay, we use panda library pd.data frame. We are converting this particular data frame. This thing we are converting. We are taking this particular file and we are taking all the data and we are saving it in data frame. So df of, let's say, Boston. Okay. At website such as Kaggle, I think Kaggle name is there. or some other websites are also there where you can use some open source data. Okay, some data are there, and you can find out the scenario which kind of data it has, and then you can practice out your everything. Okay, so many data sets are available online also. Okay, and when you run your analysis on it, you will get good practice, right? Now this thing is there, and okay, this thing, and what I want to do, I want to save this column names dot, which column will be equal to this particular column names. Okay. This thing, and then I want to know the head of the file. Okay. Okay. This data set you may have got last time also, right? Sir may have told you about this. So here we have so many data, right? Okay. You remember this one, right? This Boston data set, right? So let's say one function is there to find out the shape of the data. Okay, so how many rows and columns are there? I think that to find out the shape. So let's say current shape, or you can say old shape is there for now. Okay, just to find out old shape. Okay, our data is in df1. Okay, so df underscore Boston BOST1, I'm writing correctly. Okay, dot shape. So if I run it, I will get, okay, old shape or current shape, you can say. Okay, in currently I am having these many rows and these many columns. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13, yeah, 13 columns are there, and there will be these many rows we'll have. Okay, so we'll try to find out outliers in one particular column, let's say dis. Okay, okay, we'll try to find out, and then we'll, whenever we have outliers, how we'll deal with it, it's a different kind of issue. Okay, it's also a different kind of analysis. Okay, here when we'll find out those outliers, we'll remove those, because the data set is large enough. Okay, so we can remove that part also. Okay, and it's not like we'll be replacing those outliers with some other data, right? So mostly, if you read in theory also, so how to deal with outliers, there will be some different methods. So we are one method which we are doing, which we will be doing, we'll be finding those outliers and we'll be removing them. That's the thing which we are doing. There are some other methods through which we'll be dealing with them in another way. Okay, so if you read literature or so many different kind of analysis are also there. Mostly here we will be simply removing those outliers. That's the basic thing which we should do. So we have used that seaborn library also, right? So here we'll also use the same thing. Okay, so import seaborn library is there. Import is SNS. We'll try to plot some box plot. Box plot, big box plot is there, and here we'll plotting box for this particular data set. Boston DIS. Do you remember what is this DIS? Anyone? Do you remember what is this DIS? Which kind of data it is? It has some value, right? And which kind of parameter it is? Anyone? Okay. Yeah, it's the website. Google data. So this has weighted distances to 5 Boston employee centers. Okay, this is the meaning of this particular name. Okay, weighted distances to 5 Boston employee centers. Okay, fine. Area. Okay, okay. So now I remember now. So these things are there. So we have some outliers, right? We plot this particular box plot, and then we find out these outliers. So now what we can do, we can plot some other diagrams also, but like I told you in the last time, how we will deal with these outliers? We'll find out the interquartile range, and using those interquartile range, we'll be replacing those values. Okay, so we'll be dropping those indexes. Okay, we'll be dropping those indexes. So here I'm doing it in a different way, but if you want to use the same function which you used earlier, then you have to use a bit of your own mind. Okay, so how will we find out the first quartile? We NP library and okay. If we have not imported then let's use okay. NP dot percentile of which part DF Boston this, and here percentile 25 and interpolation equal to midpoint. Okay, if you forget this, you can Google it, right, just to find out what kind of inputs it need to be passed, right? Okay, this is first quartile. I'm copying it, and I'm also finding out the third quartile. How will you find out? Q3 share 25 which is 75, and interpolation will be midpoint only. And what will be my interquartile range? It will be Q3 minus Q1, right? Q1. Okay, and this thing is there. Okay, let me run it first. Print Q1, Q3, I, QR. Okay, sorry. Okay, so my first quartile, this is third quartile, and this is my interquartile range. So last time, how we'll find out those upper bound, lower bound values, right? Whichever value which exists 1.5 times of interquartile range from the third percentile, third Q3. Okay, from Q3, if it is 1.5 times of IQR, then those values, those data points will be our outliers. Okay, here we'll be doing the same thing. Let's say I want to find out the upper bound. Okay, so those upper values will be using numpy. Here, find out those values of what DF Boston. Okay, of this particular value data set. Okay. We are doing it the second time, but now I think it will make more sense to you. From Q3 plus 1.5 times of IQR. Right? This thing is fine, and let me run it if there is anything wrong. Okay, same thing we have to do to find out lower quartile. NP dot pair, where this is Q1 minus 1.5 IQR. Here it should be less than. Last time we made this mistake. This time we want to. Okay, so here we run it again. Now I have this. If I want to print it, I know. And if I want to know the lower one, it's empty. Okay, so only these indexes we have. Okay, these are those indexes means these are the rows or columns. Okay, in that particular column, these are the rows number 351, 52, 53, 54, 55. These things we want to drop. Okay, in lower there is no data, but we cannot write, like we cannot be sure that every time it won't be there. So in our main data set, which was our main data set, df underscore Boston. It's not like that key we will be only be removing those values in this Boston DIS data set. No, we'll be removing this entire row in the Boston data set, right? So the entire row will be removed. So here we'll be dropping, and here we'll use upper 0, you can write upper 0, upper also both will work, and here we'll write in place equal to true. Okay. 2 or 2, capital 2. Yeah. And same thing, we will want to be drop those values which are in for lower. WR place equal to true. So I have done this. Now I want to know what is the new shape of this particular Boston. So new shape means how many rows and column it has, right? So just to compare, this is my new shape. This is my data frame, df Boston. Here we want to find out the shape. How many rows and columns are there? So earlier it was 506, I did, right? Remember this was okay. Here it is there. Boston data set 506. Right? 506 or the old shape is also edited, right? Oh yeah, here. Old shape. Earlier, these many rows and these many columns were there. Now we have removed a few rows. Why? Because those rows were containing outliers, which were affecting our analysis, right? Our entire data set. So whenever we'll find some data set, we'll try to find out some missing values. There are some missing values, we'll try to replace them. But if there are outliers, we can remove those entire rows. If the data is large enough, these things won't matter much. Okay. Okay, this is the basic understanding of this. Okay, now what we will do, we'll cover up one another topic. If you have any doubt, you can tell me. Any doubt till now? We have replaced missing values, and we have covered this outlier part also. We'll try to cover the correlation part also. And I'm taking 5-minute break. Okay, just give me 5 minutes. You can also take 5-minute break also, right? Then we can start again with that correlation topic. I think correlation we can start. Okay. Any question? Here, were you able to do this? The simple stuff. You have to drop those indexes. If you would have used that same old function, you just need to pass that what we had. Let me check. Last time what we have replaced outliers, right? Those outlier was there, right? One outlier OTLR, yeah, some outlier function we have proposed, and in that we were just passing that particular data frame because we don't need to write this stuff, this stuff again and again, right? This thing, this DIS, there it was common. So because of this reason only, I have written that particular, or I have told you to use that particular function because it will be repetitive. Every time whenever you want to use this outlier, you don't need to write it for every other of columns or anything. Okay, just call that particular function by passing on this data. Okay, it will give you outlier indexes, and you can drop those values. Okay, so those rows will be removed from your data set, and you will have a new data set, okay, without outliers. I'm giving you 5 minutes. Just give me 5 minutes. I will come back and just pausing it.
Is anybody saying anything? Gaurav, you are on mute.
Sorry, that's what I was saying. Am I audible? Okay.
And so I was seeing the change in graphs, but I could not understand if you were speaking or not.
Oh, okay. Okay, sorry. I okay. So I will repeat again. Okay. I was okay. Where I was? Yeah. Okay. Sorry. So what I was saying, I was explaining the correlation. Okay. Explain the correlation. Why correlation? Because whenever you do this particular any kind of analysis, you need to find out if there is any relationship exists between two variables, two or more variables. Okay, so it may be possible that one variable is entirely dependent on another variable, or maybe it is depending on that, but maybe negative side. Okay, and maybe these two are not dependent. Okay, or maybe these two, they could depend on another third variable. So in the first part of this particular diagram, which you'll see here, when one variable is increasing, another one is also increasing, right? The scattered plot, and its data is very less scattered. That's why we call it strong positive correlation. Okay, in the second one, when you will see data is scattered, agree. But when one variable is increasing, another variable is also increasing, right? Some data point, right? A bit, you can say that this kind of file line, okay, this kind of line will be for this particular kind of scenario. Okay, here in third one, there is no correlation, right? When one is increasing, you are not sure, right? Is whether another variable is increasing, decreasing, or is there any relationship exists. So when you will check for correlation, you will say that it is coming very low or less, near to zero. Okay, so there is no correlation. Okay, and in the last one, it will be a strong correlation when one is increasing, another one is decreasing. So correlation is there, but the value which will come, it will be a negative one. So it will be, and this correlation, when we analyze, it exists between 0 to 1. 0 means exactly there is no correlation. Okay. So I have one data set with me. Okay, where is my point? Okay, I have one data set with me. I will share it with you. Okay, if it required, we'll do analysis on that. Okay, that is okay. So I'm sharing one file, age birth data. Okay, we will receive it, and if I open it, you will see. Okay, so in this age birth data, it's related to data of few medical patients who have given birth. Okay, who recently given birth, but how many gestational periods are there? How many weeks that particular baby was getting carried in their body? So we'll try to find out, is there any correlation between these two, right? So what we can do, we can read this particular file, and we'll say this parameter and this parameter, and show me first first what we'll do, we'll try to create one scatter plot, we'll analyze it. Then what we'll do, we'll okay, after doing that, we'll find out that particular correlation. Okay, so there are some formulas are there, right? Manually also we used to do when we were getting introduced for this particular correlation. In Excel also you can do. So here we'll use some formulas and all, then we'll do. So let me minimize it. What's the name of this file? Age birth data. Fine. So it's in my same directory. Okay, I will do it for another data set also, but let me see if I am able to do this for this data set. Age birth data. Okay. The CSV file is there. Okay, we have this kind of name. Okay, age birth data, birth weight is there, gestational period is there, and find data. The name of data frame is DF. What is in DF? 1. I cannot pass the right? Okay. Okay, this is my column name. I should have kept it a bit lower with so you don't need you अगर ये नाम छोटा होता तो अच्छा रहता, but ठीक है. Okay, let's keep it for now. And you have this kind of data set. One data gestational age, weeks data is there, and one weight data is there. So here what we are trying to do, we are trying to find correlation between these two variables. Okay, we'll try to find out whether it is a positive relation or any kind of which kind of relation it has. Okay, so numpy. Okay, just before this we'll try to do some analysis. Okay, so from numpy we'll import. Okay, we'll import data sets such as mean, standard deviation, and okay, and which kind of data we'll need for some random data set also. So here we won't need it random, and we'll use we want to plot scattered plot. Okay, so we'll use that library, the library which we'll use earlier. Okay, matplot library. Okay, the other library also you can use. So I'm just trying to use this one so you won't forget this one. This is okay, I'm writing it now. From this library we should import plot. Okay, with this we will be able to load this. Okay, now we will see that with first data set, and it's my data 1, right? Data 1, we want to values mean, and then data mean and median. Okay, two values we want to print, and the same thing we want to do with data set 2 or column 2. We want to print mean. Let's say we combine it so that std standard deviation. Okay, so here to find out the mean, so we'll say mean of the data set 1, standard deviation of data set 1. Same thing we will do for data set 2. Okay, what is my data set 1? Data set 1 is this one. Okay, stationary peaks. Okay, okay, not here. Data set 1 only. And now what is my second one? Second one is for DF and birth weight. Right? Birth weight is there. Data frame. Okay, I'm just trying to find out the mean values and standard deviation of this particular data set. So if I run it, that mean of first data set is 38 and standard deviation is 3.06. And for second column, it is the weight, the mean value we have is 2902 grams. It's almost 2.9 kilograms, right? And the standard deviation is 675 grams, around like this only. So using this pipe plot function which we have imported, let's say I want to plot a scatter plot between these two. So data set 1 and data set 2, this is my first data set. I can also write it like data 1 and data 2 equal to this part and this part. Okay. Okay, this thing after that we'll say type plot equal to 5 dot show. So this kind of data set we have. This is the scatter data plot, right? So now I can also write some x on x-axis what I want, on what on y-axis what I want to write, right? Those things I covered in the last class. So just to save time, I'm not writing those here, but here is a number of weeks, right? So mostly we can see that just around 36 to 42, right? This is the majority of those deliveries happen in these weeks only, right? 36, almost 9 months to 10 plus a bit month. Okay, some data sets there. So now I want to find out if there is any correlation between these two. With my analysis, we can say that there is positive correlation. Okay, it's a strong one. It's a bit strong, but how much strong? To know that, I need to know those things. So to find out the correlation, we have one formula, right? Pearson's correlation formula. Correlation equal to covariance divide by what? Correlation equal to covariance. Covariance. You remember the formula? Pearson's correlation formula. Covariance between x and y. Let's say we have two data set, the correlation between x and y, and then standard deviation of x multiplied by standard deviation of y. Okay, so either you have to find out these, at least for to do that you have to find out this particular value covariance. Okay, you know this standard deviation, you know this standard deviation. Okay, or what you can do, you can simply write out or find out this particular correlation using some advanced function. Okay, so that you don't need to pass these values, but just to practice you should be doing that. Okay, now before going for correlation, we should find out the covariance, right? How to find out the covariance, or you can write also, correlation between these two variables. Anyone remember the formula for this covariance? It is like the summation of x minus x bar, you can say summation of x minus mean of x multiplied by y minus mean of y divide by summation of this divide by n minus 1. Right? So either you can do it manually or you can use advanced maths function, right? So from I want to find out the covariance. So in which library it exists? Covariance. Okay, it exists in NumPy library also. So from NumPy library we'll import covariance, COV. Okay, and then find out this value. So you want to find out this covariance between these two data sets. Okay, these two data sets. So just to save time, I don't want to write it again. Data 1 equal to data 2 equal to. What is my data 1? Data 1 is gestation. What is my data 2? Data 2 is birth grams. If we have done this earlier, it would have saved a bit time. Okay, data 1 is there, data 2 is there. You can also write x, y, anything you want. Right? Data 1, data 2. What do you want me to use? X, y or data 1, data 2? Let's say we'll use x, y. It's all up to you. Okay. Okay, now we have this. So find out the covariance. We have imported this cov function. It will give me covariance between x comma y.
You need to write from from NumPy import.
Okay. Yeah, good. And print it. Anyone explain what is covariance? Anyone? We know what is covariance. Anyone?
Okay, so in simple terms, I mean, so covariance is a measure of joint variability of two random variables.
Yeah, you can say something like this. Ultimately, we are talking about the relationship between variables, right?
Yeah, the relationship of two variables is what it indicates.
Yeah. Okay. So mm, I have this particular covariance with me. Okay. So either I can use that part, this value, divide by standard deviation of x, standard deviation of y, and do it, or I can use instead of covariance. I also have, I think, formula for correlation also. So correlation for Pearson's, this formula, this thing we written, this is Pearson's correlation formula, right? Pearson correlation coefficient. So this Pearson's correlation formula, the Pearson's name is there, I think. Pearson R. Pearson's formula is there. Okay, we want to import it. This correlation value and sorry. Then x and y we have written, right? X comma y. Pearson's correlation. What I to say, we cannot import Pearson from number P E A R S O N R. Cannot import. Let's say I forward this stuff. What will I do? I simply Google it. Pearson's Python. Okay. Correlation Python. Correlation coefficient. This thing is there. This thing is there. What's the Pearson are same thing is there. We are also they are using it from another library. Okay. This is sci pi.stats. Okay. So NumPy, it was from Python library. Okay, now have these values. Pearson correlation value. It gives me two values. Okay, so the second value is not important for me, so I am just declaring two variables. Okay, one is this one, another one is just another variable name. Okay, it will give me two values, so we'll run it. Okay, this is my Pearson's correlation coefficient. I can write here also. Pearson's correlation coefficient, or whatever you want. Okay, so this value which came is 0.81. So whenever these values it is greater than 0.5, 0.7, 0.8, it's a strong correlation, right? We can define some limit that if it is more than that, it means it is a strong one. Strong relation limits whenever it is near to 1. Okay, so by doing this you can find out this Pearson's correlation formula. There are other correlation coefficient formulas also, like Spearman and some other things. Some other formulas are also there. So you can, if you need those correlation coefficient, then also you can Google it, find out those names, and just simply find out the value. Okay, these are very basic stuff. Okay, but from which library you want to use? Okay, let's say I forgot. I thought it was from NumPy, but when I Google it, I found out it is from some other library, sci.pi.stats. Okay, so let's say here in this example that we did, For two relation, they find out that it's 0.878. Okay, so with different variables, it will be some different kinds. For this example, this is a linear one. Okay, it's a non-linear relationship. So here it will be very different. But okay, for x3 y3, x3 y3 is this one. This is a linear relationship. Okay, so when you plot the scatter graph, you will get to know, you will have a bit idea whether it is a linear or non-linear. Okay, and this particular formula which we have, it is for linear relationship. Okay, and some other stuff also you can find out if you search more. Okay, if you need any more values or any more formulas, okay, so it's a good practice to use inbuilt formulas only, because if you go on and write out all these things, you may get confused, or you may write something wrong. You may write something wrong. So if you just simply want, just do it with these formulas, and you will be getting those values. Okay, but for me, let's say I'm good at coding, or I want to do it, let's say in my first handout, I want to do it on my own. So I have written these formulas on my own. Without writing these, also I have find out these values, correlation, just with the formula only. Okay, if you don't want to remember the formula, fine, just import these libraries, import this function, and you can do it. Okay, so I think there are more topics also. Okay, but we have time issues, and I don't think they are much important to us right now. Okay, considering this particular course. Okay, now if you have any question, you can ask. You can call it a day. Call it a day. Just remember this, there is some website called Kaggle, okay, kaggle.com. Here you can find many data sets. Okay, sir may have told you. Okay, just read those data files, download it. There are some good projects, like some projects you can say that how to analyze these things. Okay, how to find some sport, how to find a car detection. Some trending data sets are there. Okay, they may be related to AI and all, but you will have some missing values, you will have some outliers. Okay, you have to replace those values, then only you will be able to start your analysis. Without doing these parts, if you just start your analysis, nothing concrete may come. So you should be careful. Okay, any question? If you have any question, you can tell me now, or I think this will be my last class. Okay, there won't be any class after that. I'm stopping the recording.